Hello everyone, this is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering, Coimbatore. So in the last video we discussed about the basics of image compression and types of image compression. And in this video we are going to discuss about lossy compression, that is transform code. Let us see the recap of the previous. So the data compression which are used to mainly for storage, to reduce the storage space and to increase the transmission speed, cost efficiency, and there are two types of compression methods, lossless and lossy compression. So the lossless compression is a type of data compression where the original data can be perfectly reconstructed from the compressed data without any loss of information. So this method is ideal for situations where preserving data integrity is critical. And the lossy compression, it is mainly used to reduce the file size by permanently eliminating certain data, typically redundant or less important information. So while the original file cannot be perfectly reconstructed, lossy compression usually aims to maintain a level of quality that is visually or audibly acceptable. So common lossy compression techniques are JPEG and MP3 MPEG. So the main advantage of lossy compression is higher compression rates and ideal for large media files. So the main disadvantages are quality degradation and it cannot be reversible. So let us discuss transform coding. So transform coding is a lossless compression. So transform coding is widely used method in image and video compression, that is JPEG and MPEG. The basic idea behind the transform coding is to convert spatial data, that is pixel values, into frequency domain data, where most of the useful information is concentrated in a few coefficients which can be compressed efficiently. So this is the block diagram of transform coding. So the input original image that is need to be compressed is typically represented as a matrix of pixel values, that is intensity. The pixel value, the matrix value is intensity or color values. So that is n into n images is given to the construct sub images, and it is forwarded to the forward transform. So in forwarded transform, it converts the input image data from the spatial domain, that is pixel domain, to the frequency domain, where the data is represented as coefficients corresponding to different frequencies. And the common transform methods are discrete cosine transform and discrete Fourier transform, wavelet transform. So the discrete cosine transform widely used in JPEG compression. It separates the image into high and low frequency components. And coming to discrete Fourier transform, it decomposes the image into sinusoidal components. And wavelet transform is used in more advanced image compression methods like JPEG 2000. So the output of the compressed image is a set of transform coefficients where most of the energy is concentrated in a few low frequency coefficients, and high frequency coefficients can be reduced, discarded, and it is given to the quantizer. So the main purpose of quantizer is to reduce the precision of the transform coefficients to achieve compression. It is essentially limits the number of bits used to representing each coefficient. So there are two types of quantization. First one is uniform quantization, where all the coefficients are scaled and rounded uniformly, and non-uniform quantization. So different coefficients are quantized with different levels of precision depending on their importance. And the compressed data, that is symbol compressed data. So the output of the symbol encoder representing the compressed image data that is now ready for the storage or transmission. The file size is significantly smaller compared to the original image file. And coming to the decoder unit, so it reverses the decoder unit, mainly used to reverses the symbol encoding process. It reads the compressed bit stream and reconstructs the quantized coefficients using the reverse of the coding technique applied by the symbol encoder. So the output is required quantized coefficients that represent the frequency information of the image in a compressed form. So the inverse transform, it converts the frequency domain coefficients back to spatial domain. So this step restores the image from the frequency components to pixel values. So the common transform method used in the decoder side or inverse discrete cosine transform, inverse discrete Fourier transform, and inverse wavelet transform. And coming to the advantages. So the advantages of transform coding are energy compaction, compression efficiency, reduction of redundancy, and flexible compression control, smooth image reconstruction, and it can handle various image types. The main disadvantages of transform coding are loss of information, block artifacts, and that is in techniques like DCT, the image is divided into small blocks. So the compression in the frequency domain can lead to block artifacts, and complexity, that is computationally intensive, and edge distortions are the main disadvantages of transform coding. So thank you. Hope this video will help you to understand the basics of basics of image compression, that is lossy compression, lossless compression, and transform coding. Thank you.